let's do this problem. Find the total differential df of the function of x and y, which is equal to y times the exponential of x plus y. So the total differential df, if you remember from the definition, will be the partial of f with respect to x times dx plus the partial of f with respect to y times dy. Okay, and dx and dy are left as unknown variables, meaning that our total differential df will be a function of dx and dy. Okay, so in order to calculate this, we first have to calculate the two partial differentials. So partial of f with respect to x. So we have to do the partial differentiation of this with respect to x. So we assume that y is a constant, so we leave it outside, and then we do the derivative of the exponential of x plus y. So if y was a constant, what would be the derivative of 2e to the x plus 2? What would be the derivative of that? It would be equal to 2 times the derivative of what is in the exponential, x plus 2, the derivative is 1, so 2 times 1, times the exponential itself, right? So that would be the derivative. So that's exactly what will happen here. But instead of 2, we are using y. But since we are doing the partial with respect to x, y acts exactly like a constant. And therefore, the partial of f with respect to x is equal to y times exponential of x plus y. Okay? Don't be confused by this. Remember your rules for differentiation, for differentiations, including exponentials, and then it's very easy to do partial differentiations. Okay? Now, what about the partial of f with respect to y? That gets even more interesting, because now we have two functions of y multiplied together. So we have to use the product rule. Okay? So let's remember from last semester, what would be the derivative with respect to y of y times the exponential of 2 plus y. So I substituted x by 2 so that it is a constant. Okay? What is the derivative of this? We need to use the product rule. So this is the derivative of y, which is 1, times the exponential without derivative. Now plus the y without the derivative times the derivative of the exponential with respect to y. What's the derivative of e to the 2 plus y? It's the derivative of 2 plus y, which is 1, times the exponential itself. So this. Okay? So this is from last semester, but now instead of 2, we have an x. And since we are doing the partial derivative with respect to y, we can treat x as if it is a constant. And therefore the result is simply exponential of x plus y times the exponential of x plus y. Okay? So this is the partial derivative of f with respect to y. So now we can build the total differential, and it's as follows. df is equal to this here, y exponential of x plus y times dx, plus this, which I'm going to group as 1 plus y exponential of x plus y times dy. Okay? If we wanted, we could write this as exponential of x plus y times y dx plus 1 plus y dy. Okay, and this is the total differential of f, and it is a function of dx and dy. So this now tells you how much the slider changes when we change x by an amount dx and y by an amount dy. F will change by an amount df given by this expression here. Okay? So thank you very much. See you in the next video.